So what you were saying was you tried to sort it. Now, for those of you who are confused as to why you might want why sorting might be a thing to do, let me go ahead and do array list in class, whatever. Okay, yeah, this window, sure. So right, we're trying to solve the permutation one. That's the fourth one, I believe. List xer, okay, whatever. So the idea here is that if I've got two words, so let's work with words for a second. If I've got two words, wolf, and if I've got flow, if I sort the words in alphabet, the contents of these strings in alphabetical order, put them in alphabetical order, they're both going to come out to be flow, no matter what. So the idea here is that you can check if two things are permutations if you sort them. If you sort them and they come up in the same order. So, so I'm going to quickly go over this. What you were saying, where you were trying to implement the comparator. Were you trying to implement the comparator or comparable? Got it. Okay. So the idea here is that it's a very good idea, and you can do it like this in like 3 lines, if you can get it working, which is the issue. Public static Boolean is permutation. Okay, and it's going to take in list E some list of items A and some list of items B. And the idea here is that we've got 2 items A and B. I'll call them list A and list B because I've got space, right? You've got list A and list B, and they exist here. And the generics are useful here because it's saying, hey, you've got now we can be assured that these lists have the same types of elements. So we don't have to bother checking if we can even, compare the two and check if they're equal. Because they're the same, we know they're going to be the same type of element, so we don't have to bother casting them to try to call the dot equals function on them. Okay. And what we found out, and so if you do a bit of digging, so I'm going to, again, just return true by default to quelch this error. And if you do a bit of digging, right, first off, there's a list dot, and there is a sort method that requires a comparator, which means if we don't know how to sort things, then you provide something called the comparator that tells it how to sort. That's not really something we're going to use in this class because most of the time, that gets into some weird Java stuff. But most of the time, what we're doing is that we would like to sort things. And there's this, so all the data structures that we're going to be using that are built into Java this semester are things called collections. But let's see. Yeah, I think it's collections dot, and I think there's there's a sort method for collections. And the idea is here, given us a collection, you can sort the collection. So all lists are collection, all sets are collections, whatever. It just puts it in the order for you. Okay. So, and if you Google online, they'll say, oh yeah, this is super easy. If you want to sort something, just throw it into collections, and it'll sort it in place for you. And you come up with this code over here: collections.sort list A, collections.sort list B, and then you just simply would return list A dot equals list B. Assuming, well, let's go ahead. Yeah, and that's the issue you're getting. No, I'm just checking to make sure that it is that it is going to be doing it in place. That it does not. Returns nothing. It does it in place. And this is the issue you're running into, which is that it's saying it can't sort it. And if we look at the error, which I'll read for you because, again, just UI stuff. No instant required type. List of T's. You provided me a list of E's. No instances of T's exist so that E conforms to comparable ? Super T. World? Okay, so maybe I should switch it to T's instead of E's. But no, that doesn't do anything. And what it is that the idea here is that you can't sort everything. You can only sort things that can be sorted, things that have a ordering. By I believe the requirement is that it's a total ordering for sort. Oh, natural ordering. Got it. So natural ordering. So that gets into modern algebra kind of stuff. But the point being is it makes sense. You got to be able to put stuff in order in order to be able to. And the way Java looks at it is it says in order to put stuff in order, you have to be able to compare the two things. So they have to be what it calls comparable objects. Now, so integers are, and let me just quelch this for a second. Integers are comparable, and strings are comparable. PSVM. So meaning that and the comparable. Let's just go ahead and open it up. It's an interface. It provides one function called compare to, which allows you to compare stuff, which is useful for sorting because that's what it's going to be doing, comparisons and the like. Basically checking if things are bigger or smaller. We can see this with so I'm going to use the integer class so I can get access to this. Integer x is equal to 5. Integer y is equal to 10. Very clear which is bigger. So, and if we call sout x dot compare to y, you get negative. It's going to print out -1. Just give it a second. Okay. See, -1. And if you do y dot compare to x, you'll get 1. And if you compare either to themselves, you'll get 0. So the way compare to works is that the documentation says if you're implementing compare to, you basically have one rule, which is you basically have to follow this rule, which is if A comes before B, then return a negative number. If they're the same, return 0, and if A comes after B, so in the case of numbers, if the A is bigger than B, if X was bigger than Y, we'd return a positive number. This works on things like strings too. And it doesn't say -1, it says negative or positive number. So if we do apple and durian, apple.compare to durian, it allows us to, it says -3. It provides a negative number. And if you notice, A is 3 letters before D. It's providing kind of a letter distance. So just a quick aside there. So Java, in order to be able to sort things, they have to be comparable. Yes?
You said if X is before Y, then it prints -1? Or
A negative number.
it prints a negative number.
A negative number. You're only ever going to check if it's less than 0, greater than 0, or equal to 0. String and the reason it's provide that is that so some classes can provide some more information for other tasks that might be. So what we need to do is enforce that these types that we are importing, which I'll switch back to E, can only be comparable, because if they're not comparable, we can't sort it. Because right now we're saying it could be a list of anything. It could be a list of integers. It could be a list of objects. And objects, you can't compare them to each other, not with the compare to method. It's the top of the class. Scanners are not comparable. How in the world would you be able to sort them? So if we restrict the type, which, is kind of weird, we can actually do that. And the way you can restrict a type, and we'll be using this much later in the semester, so you don't have to worry about this now. We'll be using it in around week 7 when we get to binary search trees. It's just by doing this. E extends comparable E. So in other words, basically it's saying E, we're saying E is a generic, and we're putting a restriction on the generic that it is a subclass of things that are comparable to E. In other words, right here we're writing, we want only things that compare to themselves. And the reason I do it like this is that it's the easiest way to write it, because I don't have to write weird things like question marks and tell you, oh, that's the wild card symbol, because we're playing poker now. No, E comparable E, it's good enough. There's lots of magic stuff you can do with generics, but here is basically saying, but that will now say, hey, we're restricting the list to be comparable, and now, hey, three lines of code, and you're good. This is one of the things, one of those annoying things about computer science is once you know a few things, you can actually do quite a bit of, you can end up doing quite a bit of research, and it ends up being spent to write like 2 lines of code, which can be very frustrating sometimes. But that isn't necessarily the way we want to solve this, because I want to check if anything is a permutation. So this is really good only if we are restricting our types to that. What about solving this manually as opposed to sorting it? Okay, let's go ahead and copy this, and we will paste this over here. And now let's go ahead and instead of this, we are just going to go back to doing E's, right? A list of things. So in order to make sure that these 2 things are permutations, they have to have the same number of each item. Yes, question? Minesweeper?
Oh, my answer for it.
Oh, what's your answer?
Oh, it's like a hash map with the type B, and then the
Yep, that is correct. That is the week 10 answer for this question. That is the way you would solve that. And it is also the most time efficient way to solve it. That solves it in O of n time, as opposed to the sorting it, which takes n log n, as opposed to the method we're going to go over now, which takes O of n squared. That being said, the way we're going over now is space efficient, so there is that. But yes, using a hash map, or those of you who came from Python, a dictionary, or in those of you who know JavaScript or Lua, an associative array. I'm not sure if it's called that in JavaScript. I think it's called that in Lua. They have different names. A hash map, hash table, associative array, dictionary. So those are basically the data structure where you do arbitrary key value mappings. We learn about that as though it's the first time in when we cover hash maps and hash sets in around week 10. So is permutation. So rather than doing that, we're going to just manually count. But that's what we need. We need to count for each item. We need to count how many times it occurs in A, how many times it occurs in B. If it differs, then it's not a permutation. So we're going to assume that they're permutations until we're proven otherwise. And I'm going to keep accidentally capitalizing true and false because I'm teaching I'm teaching Python at the same time. And for some reason, Python made the amazingly silly decision to capitalize true and false. Okay, so first thing we're going to do to make this easier for us is we are going to say if list A dot size is not equal to list B dot size. And again, that's just my, this is just simply exclamation point and equal, explaining the ligatures, and then I get a big fat not equal sign. If the sizes are not equal, then they can't be permutations. They just can't be. Return false. Okay. Next. What should we do? Well, what we need, so this is what makes it weird, because we're going to write a loop that we haven't had to write before, even though it's like the same, but basically we're going to loop over the same loop over the same thing twice. So and I'll do it as a for each loop just to make it simple for right now. So again, if you haven't seen these for loops, these are the way it works in Python. They're wonderful. They're great. They are very concise and easy to read. And you read them as for each item of type E, and you read that colon mark as in list A. So for each item in list A. And the type of that goes here. Okay? And that's equivalent to, as we'll see, and that's equivalent to basically doing this loop right over here, which I'll need in a second. For I int I is equal to 0, I is less than list A dot size, and then using list A dot get to retrieve the item, right? So this is a common mistake we see on exams. Don't do that. Subscripts are bad here. We don't use subscripts. We don't get the chance to use subscripts anymore. We got to use the dot get method. It's annoying. So dot get I and E other. So it's equivalent to doing that. So this loop is equivalent to doing this loop. But I've got ahead of myself. What we're going to do is that for each item, int count A is equal to 0, int count B, we're going to count how many times this item occurs in A, how many times this occurs in B. Make sense so far? So for each item, initialize the counts to 0. Okay, so now we iterate through every item, including the one we're currently counting in list A, and we're saying if item dot equals other, if you'd used equal whatever, doesn't, the algorithm's still going to be, effectively correct. If item is equal to other item, then count A plus plus. Then we go a bit lazy. We say we highlight it, we copy it, we go ahead and we just simply paste it, and we switch all the A's to B's here to iterate over B. So we iterate over this list B, get every item in list B, and say, hey, if it's equal to that item in list A, count B. And this is where, and we only have to iterate, the outer loop only has to go over list A because we know that they're the same size. Since we know they're the same size, that means that if one has items the other does not, somewhere we're going to get a miscount. So that's going to be useful. So over here, and that's what it comes out to. So first we check to see, are they true, are they the same size? And then we say, hey, count the number of times for each item, count the number of times it occurs in A, count the number of times it occurs in B. And then finally, last step, if count A is not equal to count B, then we have proven that this isn't a permutation. So if we get a miscount on any of the items, return false. And that's it. Once we're done, we can return true. And that is a lot of lines. It's lines 18 to 47. That's a lot of lines. Let's see. Let's go ahead and, drop that on Discord, shall we? Yeah, this makes it useful, having the Discord there. So give me a second. And then, Rosen's classes, and then it's giving me all those warnings about streamer mode, so I don't accidentally, it's nice that it doesn't accidentally show usernames. And the nice thing is that I can syntax highlight it. Yeah, go ahead and check it out in Discourse. It's nice and syntax highlighted. In case you're curious about how to drop syntax highlighted code in Discord, you start with 3 tick marks to start a code block, and your code block ends with another 3 tick marks. So first off, put your code in there, and then if you want to syntax highlight it into the appropriate programming language, you just put the programming language here. So that's what I just simply surrounded the Java code with that before I dropped it in Discord. So that'll make you look nice and professional and stuff when you're sharing code or talking about code on this Discord or another one. So there you go. That's available for the class. If you need it later and you're not on Discord, just refer back to this recording. Yes?
If statement where it compares count A to count B, is that supposed to be in the for loop with the, like it would just like
it is. It's in the outer for loop. So count A, count B. So let me. There we go. So it's inside this outer for loop.
yeah. So, but wouldn't it like return it like before it goes through every item?
Well, it's gone. You're checking every item.
Oh, I see.
You're checking every item individually, and that also annoyingly means that we're going to be doubling our work. Where if we've seen an item before, every item we're going to have to count it each time it appears. It's annoying, but it works. In order to be clever about it, we need to use hash sets, and if we are using hash sets, we might as well use hash maps, which again are all introduced in near the end of the semester. But I like this because I like it because it's a mess. I like this problem because it's a mess, and we get to revisit later and see that, it's less of a mess to do it this way. There's also a non-messy way to do it, but the non-messy way is a bit restrictive about what the solutions are. But at the same time, how often are you checking if scanners are comparable to each other, And, in that case, if you're in that kind of case, where you're trying to compare things, the list.sort method, just to go over, list.sort, you'll see that it takes in, that the documentation says it takes in, I love being able to do this, control click there, and it says it takes in a comparator, which is that if you're trying to, sort things that can't be compared to each other, you can provide it something called a comparator, which basically says, I've written a compare to for comparing these objects. And you might simply sort them by, decide to sort them by memory address or sort them by the initialization time, which are all valid ways of doing that if they just have to be able to be put in some kind of order that's unambiguous. So there are ways to do it and ways to get around it. All right. But that is, so hopefully you've all seen that one. Again, the array lists are, the array lists aren't too bad. They're really just working with really flexible arrays. You've been working with them for a while. Again, the idea here is that you're just simply is that you're getting a much better idea of how they work internally, especially with the very last question that we'll ask. That one, solving that one does require you to understand how it does work internally. The other thing I should mention about upcoming homework, the next homework, homework 3, is a math worksheet. I know, but it's big O notation. The good news is that, unlike math homework where you just pass it in to me, it's the same rules for demoing. You show it to me, and if you get something wrong, I tell you it's wrong and tell you to go back and fix it. So there's no reason why you won't get 100 on it. For some of the answers, such as for BOGOSort, which is a sorting algorithm that only exists in the confines of pedagogy, of teaching pedagogy, that algorithm is very thoroughly analyzed. It's worth taking a look at Wikipedia or any essays worked on it to answer those questions. BOGOSort and StoogeSort are the two algorithms that basically exist purely for the sake of students to analyze them. Because they're terrible sorting algorithms, but they're hilarious. All right, any questions before I go around the class? I'm going to start from that end because that was the end I didn't start from last time. Any questions? All right. Hopefully lab went okay yesterday. I think Kenichi only had some questions about. Kenichi was unfamiliar with how to put in the grades into that, and I showed him yesterday. But otherwise, going forward, it should be fine. He's very proactive about reaching out if he runs into trouble, which is great. But anyway, if you have any questions, or issues, again, send me an email. Okay. So I'm going to go around the class.